Thank you, everybody, for attending. Goran, I only have 20 minutes, and I don't have any slides. I'm just going to show you stuff. You know, Goran wanted me to do a presentation that was super technical. I don't think anybody cares about compiler design and that kind of stuff. Plus, you can read it online, take your time with it. The point here is to have fun and see sort of what you can do. And so in my spare time, that's where I really like to program and mess with these things. And professionally, I'm trying not to do so much technology stuff because it ruins it for me. But there's really fun stuff to do. I'm also flattered that somebody finally got my last name right, as Luciani. I'm part Italian. And in my spare time, I do music. And I've done it for quite a while. I'm moderately well known among the prog metal aficionados, which is to say nobody knows who I am really, but I'm somewhat good at this stuff. I want to show you, let's see, okay, you guys see my screen. First of all, I have a very nice computer at home because I work with HP, quad GPU with 180 gigs of memory, and I have this laptop here that, like you see, has a 4000 ADA card on it, so I can do quite a lot of AI stuff on this. This has 12 gigs of RAM, and I want to show you two sort of domains as quickly as I can, one within video and one within audio, and just also a little fun thing about language models, because that's all accessible to us, even if we're not musicians. So I just put up a little cover video. You know, I usually do pretentious prog metal stuff that nobody really likes, but I did a cover of a pop song a couple of days ago, and it sounds something like this. And, you know, they told me to raise the volume, but now I can do it myself. Let's see. Look, everybody can sing along to that kind of stuff. Today it's a right? No growling or anything. I'm going to show you exactly how I did some of the special effects in this and how I did some of the audio stuff using AI. But before I do that, I want to just have a fun little bit with language models and just show you. I am the last person that will tell you that language models are stupid. I think they're awesome. But I'm very aware of what they're not able to do. And to be fair, most people aren't able to do this. So it's not really, you know, being too harsh on the language model. So, you know, in prog, it's not about making beautiful music. It is. But it's also about making things as hard on yourself as you possibly can. And my middle name is Robert Do Things the Hard Way, Luciani. So these are some lyrics from one of my prog songs. And, you know, it's classic metal where everything is a little bit obtuse and who even knows what this is about. But really the way I designed these lyrics are using a system called iambic pentameter, which is what you know, you'll find in Shakespeare or John Milton and that kind of stuff. And the reason it's special is because the cadence needs to be very specific. So this looks a little bit random, but really you have 5 syllables, and the stress needs to be on the first one starting on the line, and it really needs to match. So here it's not just as nothingness is reified. It has to be, you don't have to read it this way, but it has to work as nothingness is reified with each diagonally oriented phrase. Through Cantor's lens, we finally can see, and as you see, it works like that. Obviously, with, you know, for fun, I do some rhymes here. So for example, C, inconsistency, irony, and stuff like that. What I want to show is, let's ask ChatGPT to do something similar, right? It's studied Shakespeare. Let's go ahead and ask it. I'm at a conference about generative AI, and the audience is watching. Help me write a poem, a quatrain. Let's do a quatrain. That's 4 lines. In iambic pentameter, blank verse. The topic should be about AI stuff. Okay. Blank verse is like John Milton. That means no rhyming. It's not supposed to rhyme. Let's see if we can do that. First, let's check the syllables. In circuit's maze, the whispers form a mind. Okay, that's 5 syllables. Even the stress is correct. As code transcends the bounds that one's confined. That was cool. Through data's seas, it learns to chart a course, a silent forge of thought without remorse. Sweet. Okay, so the stresses is correct. It doesn't always get the stress right, but it rhymed. Bad bot. No. Bad LLM. It rhymes. I said blank verse. That means no rhyming allowed. Do again and do it right this time. Yeah, apologies. Here's the quatrain in the, oh no! It is impossible. I use this as a tool to find nice analogies and stuff. It will not produce a poem that doesn't rhyme. So one thing I tell my customers is they really have to get a sense of the personality of the model that they're working with. And here it's very, very visible, sort of, what the personality of an LLM is. But the fun thing is that there are personalities in image models and in audio models as well. And one of the reasons I really like working with musicians is they're not quite as pretentious as engineers. You know, the engineers are very worried about correctness. Is the model biased or something? Musicians don't care about that stuff. They're like, this sounds good, right? That's the only qualifier, really. There's no, you know, oh, this is granular synthesis. It's not true analog. If it sounds good, it's good. So I really love that because that sort of ties into the lesson here. If the business value is there, nobody cares how you built it, right? And then, you know, this is the ethics stage, so I think that's pretty funny. In any case, let's see here. I want to show two things. This is the track. I want to show sort of what it sounds like first, and then what it sounds like when I remade it, and then what it sounds like when my friend masters it, which just sounds a lot better. So let's just go ahead and maybe go to this part. This is the original, I think. This was released in the 90s. Very narrow stereo image. Cool, let's do it again. This is my version. I matched the levels. I do sound like Trent Reznor. Okay, anyway, and this is what my friend that mastered it made it sound like. Nice guitars, good stereo image, much more smooth. He uses a million plugins. I only use 3. But I'm going to show you one of them. So the bass in that song sounds something like this. Okay, and one of the coolest plugins is this voice transfer plugin. You guys have probably heard people using you know, AI to make themselves sound like Donald Trump or something like that. You can do that with instruments as well. And although this isn't the best example, and I apologize because I didn't record the guitars for this one, my mixer guy did. Let's see here. Recently used. Here. This model will let you transfer between instruments. And it's from the Magenta project, the Google project. And so my guitarist, when he's playing guitar, he turns on the saxophone mode and now suddenly does a saxophone solo on the guitar. You have to manage the attack and other stuff a little bit different because a saxophone doesn't really play like a guitar. You know, a pick is instant attack and a saxophone isn't like that. But let me go ahead and play the bass here. What would a bass that sounds like a flute sound like? Not really awesome, but I'll let you hear it. Oops. I don't know, that's the bassiest flute I've ever heard. Let's go for something else. A tuba. Tuba's sort of like a bass. Let's try that instead. That's the angriest tuba I've ever heard. Okay, so that wasn't a great example. You can actually do it with the voice. Let's do that with the voice as well. Go ahead and listen to myself here. Something like this. Every day. And then we add the effect. And then we make me sound like a tuba. Okay, so you get the point. This is awesome, but the coolest thing is running your own models. what would an instrument that sounds halfway between a drum, a violin, and a tuba sound like? Or a synthesizer that you've designed yourself halfway between an analog instrument and something else? This is where it's cool, is to invent new stuff that doesn't exist. Okay, let's move on. I have another thing I want to show you, which is, for many years, I've always wanted to have a female singer in my band. And it's, you know, you go around, you put up the thing, the paper that says looking for singer, and you don't find somebody. And, you know, I want somebody that has an opera background, preferably a classical opera background, but that is into heavy metal. That is really niche. I haven't gotten any hits. As it turns out, with AI, I am the best female singer in my band right now. So, I'm going to show you this tool here, which was originally made to do, you know, transcriptions for bank PowerPoints and stuff like that. But, you know, you can use it for voice transfer. So now Ariana Grande is in my band. Awesome. There's a little feature here that lets you either detect the note automatically so that it can be a little bit smart about it. And, sorry, there's very little space here on this table. Let's go ahead and infer and not play. So while this is running, I'm going to go ahead and show it's translating my voice here into Ariana Grande. As you can see, it's running in Python in the background. It's using the internal GPU, no problem. This is a lightweight one, 6 gigs of memory. It'll sit there and chuckle. Look, it's not even stressing the GPU. This is 5 minutes of audio, so it's quite a lot. You might have heard that this stuff takes like hours in normally. I have, let's see, where did I put it? I have a cursed version of this. Ariana out of tune. This one I made yesterday by mistake when I was practicing this. You guys will have nightmares. Maybe. This is what I sound like, what it's supposed to sound. Every day is okay, and this is what Ariana sounds like. Tell me who's better. Every day is exactly the same. It's good. Okay, let's skip that one. Delete, and let's go for the good one, where I've sort of made sure it follows me instead of letting her sort of choose the notes. And let's play them together. No, I never make a sound. That was pretty cool. Let's see. That did sound a little bit odd, though. Where did it go? Yeah, it's just an octave. Okay, let's go ahead and play it together. And this is what I mean that's super sweet. You fade it out a little bit so that it blends in, because there are artifacts that you could hear otherwise, but don't need to make it too obvious. Yeah, it's a bit off. Doesn't matter. Sounds like it's a semitone off. Doesn't matter. You get the point. Now she's in the band. Yeah, actually, just remove me. Yeah, it's sharp. That's no good. All right. Anyway, now I have, you know, what's the guy in Queen called? All these famous people, they're all in my band right now. They're my backup singers. So that's how accessible it is. You just go to GitHub, download this stuff, and you also can have Pavarotti as your backup singer. Let's move on. I want to show you the cool video stuff. This is slightly less accessible, and I sort of want to explain why so many tools are necessary. Let me go ahead and play 2 videos to explain the difference. So when I film this stuff, I film it in RAW with a camera called a Blackmagic, and this is what it looks like straight out of the camera. I wish this could have been any other way. Okay, a little cheesy, cheese ball. And this is what it looks like after processing. Okay, so I'm not like a professional video guy. I'm sure you could have done some of those cool effects in After Effects and done some 3D things and composited with skeletons and stuff. But I wanted to use AI to generate all that for me. And the idea was that I'm supposed to be in the shower and hallucinating. So I wanted to have some skeletons and rainbows and random crap like that. Okay, so I bring up my user interface here. And this one requires a bit more sauce. So it's running on my home computer. And you can see this is what the overlay looks like after I've run the whole process. But we're going to run it from scratch on another video instead. And I'll sort of show you how it chugs along. So these are all the components that are necessary for making that video. And once that video is done, you composite it on top of the other and blend them together in a nice way, maybe mask away the face, because that face was not quite as handsome. And, you pick what you want. We have, let's see here, Office. Perfect. Let's go ahead and run this bad boy. Q prompt. View Q. OK, so while this is running, you see this one's highlighted green. And the first thing it's doing is extracting the images, the frames from the video. I've sort of cheated here. I told it to extract every 4th frame because this stuff takes a really long time. And I'm going to explain all the components. OK, it's already hopped a couple of steps ahead. Here you can see a little preview of the, it's a little laggy over VPN, but you can see this is the shot where I'm sort of sitting at a table looking forward like that. The reason we need this many models is the following. So while this thing is chewing here, I'll go ahead and bring up the pages and explain what each model does. So the first place to go is Civitai, as I say. He's a good website, but I'm not sure how you're supposed to say it. It says Civite, maybe, something like that. In any case, this is a really cool open source community where people put fine tunes of models that are like specialized on anime, photorealism, or whatever. And you can scroll here for hours finding really weird stuff. So if you're into like cyborg, anime, blood, alien ships and stuff, there's a model for it. You will find whatever you're looking for. So I used in particular, oh, look at that, I have 2 of them open. I used this one called Protovision. And this is a guy that was stacking LoRa's and until he found a model that suddenly just worked really well and had consistency. You know, the stuff that you guys are familiar with where models mess up fingers and stuff, it's really hard to get rid of that. So like if you stumble upon a model that just happens to be good at the exact art style you like, no monster fingers and everything, you stick with it. The next one is the decoder part of the encoder. We know that diffusion models are autoencoders, which means they are shaped like this. They take all your data, put it into like a mathematical space, and then they have a decoder that takes it from the mathematical space into like a practical space, like an image or something like that. That's what this model does. It's not really a model. It's like the second half of the model. Oh, I forgot to say, this is a fine tune of Stable Diffusion XL, which came out just in December. Next, we have, the IP adapter. We don't want to just tell the model what we want. Like if we look back at the Comfy UI, that was, oh, there we go. Yeah, there's no skeletons in this one. That wasn't good. Let's make it chew just for another moment. Film still muscular man. Muscular man. No, I was going to write ultra gore. We can't do that here at this conference. Okay, you'll just have to make do with this one. In any case, I think it's quite lifelike. All right. You saw there was a little prompt that I put there. And that's because, you can text prompt, but we wanted to follow the image in order to composite it correctly. That's what this image adapter does. It combines the source image with the text prompt and then produces something. The next model here is, this was the IP adapter. Okay, these are both the image adapters. The next one here is a technique called T2I that, in order to know how the person is sitting or something else like that, you want to have a model that you can reliably use to create a certain art style. Because really with these models, you never know what comes out on the other side. And so this one is specifically made to detect people or detect faces and stuff like that reliably. So you have an extra model to do that kind of stuff. And then finally, what was Hotshot? Hotshot was, I don't even remember. Let's see, it said on the model card. Now this is for generating the video. Right, because generating video is different from generating images because you want to have consistency from frame to frame. So you need a model that, otherwise you've seen these early AI videos where it's like super flickery. This one makes sure that it's not flickery. It makes sure that it's smooth in the video. So once you have that, you end up with something like this. So, you know, it's a little bit morphing and stuff, but it's not flickery, and that's thanks to that last model, the hot shot model at the end. And you end up with a video, and then when you composite it on top, you end up with something like processed. Oh, I am over time. I would have liked to give you lots of advice. Let me give you one last website to go and visit. Go to UDIO. This thing generates music automatically, entire songs. It is just mind-blowing. Take it from me as like a pretentious jazz person. This stuff will write it will write everything. If you don't believe AI is creative after you've tried this, I don't know what to tell you. And then also, if you want to be hardcore, Karpathy put up LLMs in C. You can brush up on how matrix multiplication is done. And then the backward pass. It's not the chain rule. It's implemented in compilers. And we're back to compiler optimization, what I should have spoken about, but I showed some cool demos instead. Look, I just want to wrap up by saying that all this stuff is really accessible to everybody, and you can all play around with it at home. It takes a bit of hacking and enthusiasm, but really, the democratization that PCs and AI have done for people is astounding, and that's what I think is most inspiring. So I hope you enjoyed the little demos I had for 20 minutes. Thank you. Thanks.